Welcome back to the Deep Dive. Today we are looking at a very, very specific piece of broadcast technology.
A very expensive one.
Yeah, that too. It's the Thor Broadcast H-16DVBS-IP car gateway, and it costs nearly $4,500. Our mission today is to figure out why.
And to understand what it even does, I think signal traffic controller is a pretty good place to start.
Okay, so traffic controller. It's sitting somewhere between the old world of, broadcast radio frequencies, RF, and the modern internet, or IP.
Exactly. Its whole job is to take massive amounts of signals, say from a satellite dish, and translate them into neat little data packets for a network.
Let's get right into the scale of this thing then. The spec sheet calls it a headend piece. What does that actually mean for you listening?
It means it's the starting point, the head of the system. Think of a massive hotel, a cruise ship, maybe a university campus. This box sits in a server rack right at the beginning of their whole video distribution network.
So what kind of input are we talking about? How much can it handle?
Well, this is the first big number. It has 16 independent satellite DVB-S2 tuners.
16.
16, all at once. So it can lock onto 16 different satellite frequencies simultaneously and just process them in a single box. This is why it's not something you'd ever see at home.
16 inputs is definitely impressive, but I think the output number is where my jaw really dropped. What can it actually pump out onto the network?
Get this. It can generate 512 IP SPTS. That's single program transport streams.
Whoa. Okay, so break that down. 16 channels come in.
And 512 individual routable IP streams go out. You can send them anywhere in your local network using standard stuff like UDP or RTP.
That's the key word, isn't it? Routable.
Absolutely.
That's where the cost starts to make sense. You're not just moving video around.
Yeah.
You're gaining this incredible control to route specific channels to specific locations. Like this TV gets this stream, that conference room gets another.
You're moving from just broadcasting to intelligent network management. But we haven't even gotten to its biggest party trick. This thing is a transmodulator.
Which is a fancy way of saying.
It's the ultimate mix and match device. It's not just satellite to IP. It can handle all sorts of signal types.
Okay, so give me a scenario. Let's say I run a hospital's network. I've got satellite TV coming in, but also local over-the-air channels. How does this help?
Perfect example. So you might take your, say, DVB-SS2 signals from the satellite dish, but you also have local ATSC channels from an antenna. This box lets you take everything, convert it all to IP for your internal network, and here's the cool part, also remodulate it.
Meaning?
You can create a whole new custom channel lineup. You can take those free local channels and seamlessly insert them into your existing QAM cable lineup that goes to all the TVs in the rooms. No major hardware changes, just rearrange everything digitally.
That is incredibly flexible. But if you're mixing and matching all these different high bandwidth signals, how do you keep it all clean? I mean, translation is one thing, but broadcast quality is another.
Right, and that's where you see these really high-end professional specs, things like MER greater than or equal to 40 dB.
Which is just a number to most people. What's it guaranteeing?
It's the guarantee that your picture won't look like a pixelated mess on a big screen. It's signal integrity. Then you have something even more critical, accurate PCR adjusting.
PCR, program clock reference. Why is that so important when you're juggling 512 streams?
PCR is the heartbeat. It's the timing signal, down to the microsecond, that makes sure your audio and your video arrive at the exact same time.
Ah. So it prevents the lip sync problem.
It prevents the lip sync problem across hundreds of streams simultaneously. If that clock drifts, the entire viewing experience is ruined.
Okay, and one last piece of the puzzle here. PSISI and VCT editing. This sounds like deep jargon.
It is, but it's where the real control comes in for the operator. That's the data that tells your TV guide what's on, what the channel number is, all that stuff.
So you can edit it?
You can completely rewrite it. You can make sure channel 2 is always the hospital's welcome channel, no matter what the original broadcast says.
Yeah.
You have total control over the end user experience, and you can manage it all from a web browser.
So to sum it all up, this box is a bridge. It takes this chaotic mess of different broadcast signals and turns it into a single, orderly, and highly controllable network resource.
It's about moving from specialized hardware for every little task to, efficient, centralized packet management.
Right. So here's a final thought for you to take away. If one box that costs less than $5,000 can manage 16 satellite frequencies and output 512 independent IP video streams, just try to imagine the sheer scale of data a major national broadcast center is handling every single second.
The logistics of digital video today are, well, they're just astronomical.